Okay, today's work is continuing with distance versus time graphs. Please note there's going to be a quiz about rate of change in conversions on Wednesday. So we'll have more time with rate of change, and there's practice on Manga High and that quiz for your conversions. Those are between percent, decimal, and fractions. So our goals today, it says, are to be able to read and interpret a distance time graph as we did on Friday. And we want to use vocabulary such as increasing and decreasing. So we talked about on Friday the runner increasing his distance from the starting line as he ran away from the starting line, or decreasing his distance from the starting line as he ran towards it. We also talked about constant, so that was if he was running at a constant pace. That's what we saw when we saw the straight line segments. Today we're going to talk about speed then. So we did notice that he could be running faster when we had our little man running if he was going on a very steep line compared to a line away from the starting line that's not as steep. So this is a faster line or a faster speed than if the line was not as steep. We need to be able to create a distance time graph from a written description, and you were practicing that the other day as well. Finally, as we continue to calculate, we're going to calculate the speed of the graph, and we're using a new phrase, rate of change. We'll continue to work on rate of change tomorrow. We've talked about that. We need to have faster speeds associated with greater steepness, and of course a horizontal line, so a line where we had the runner just doing this, the motion was stopped. In other words, his speed was 0. So these are all things you guys told me on Friday, and we're just going over it again. So your agenda then is to take a note, to practice with the course notes, and then we're going to do practice on the iPad or the laptop. And whoops, that's going to be, with Manga High or that quiz. We do have a handout that will be introduced as well. It's a story graph, and you're going to hand to me the draft story tomorrow. So this is a handout for you, and here is a possibility of a story. So you're going to get a graph to write a story about, and you do not have to use just time compared to distance. You could use time compared to the volume of water in a container. You could use time compared to the amount of sandwiches left, whatever you want. Your story has to relate to the two variables that you have named. Also, in the graph I've given you, there is not going to be any numbers. So right now I've already numbered 1, 2, 3. You're going to put the appropriate numbers on. So, as an example though, if I have labeled up my variables of distance and time, and if I have labeled up my numbers, then I can then talk about this in terms of my runner's distance from the starting line. So I notice that it's at 0, 0 to start. So I'm going to say the runner starts at the starting line. That's what we know. I notice that he is running away for 1 second, because if I read up at 1 second, that's when I've changed my line segment, right? So this first line segment stops after 1 second. And I can say what his rate of running is. So that is over 1 second, he has traveled 40 meters. So in other words, he's traveling 40 meters per second. Then I see that my runner is now decreasing his distance from the starting line. So I'm saying that he has turned towards the starting line. And he's running this time for what appears to be about 0.9 seconds, because it didn't make it all the way to 2 seconds. So this is probably 1.9. And he ran at a steady rate, because again, it's a straight line. A steady rate, and he runs for 0.9 seconds. So what is the rate of change? We'll have to figure out how far he's run. It looks like this is perhaps 22 meters. So he started 40 meters away from the starting line, and he has run to 22 meters away from the starting line. So let's see, how far is that? That is 18 meters. How did I figure that out? 40 meters away, and he got to 22 meters. So that is 40 minus 22. He's run 18 meters. So he ran 18 meters over a time of, again, we thought this was 0.9 seconds. So my speed or my rate of change, is going to be his meters per second. So I had 18 meters traveled in 0.9 seconds. So I'm going to need my calculator in order to calculate that, and let's divide 18 by 0.9. And I get the value 20. So that means he has run for 0.9 seconds at a rate of 20 meters per second. Then I see, let's use a different color here, then I see the runner turns, because again it's starting to increase his distance from the starting line. So he turns and he's running towards the finish line. I'm talking about a direction. And his speed is changing. This is not a constant speed. Okay, and what his speed as he reaches the finish line. He is increasing. Okay, how do I know he's increasing his speed? How do I know he's not slowing down? Well, towards the end of this segment, this is very steep, and this is not very steep. So I can tell then that he's going from not steep to steep, or in other words, sort of slow towards fast. And he reaches the finish line after 3.4 seconds since the start. So if I sit at this point and run all the way down, I can see that that was 3 seconds, and every grid line is 0.2 seconds, so this is 3.4 seconds since he started his run. The last section here is flat. Right, so this is flat. So what does flat mean? Oh, he has a speed of 0. He is standing still for the last 0.6 seconds that they were tracking him. It took 4 seconds for all of this to take place. So the rate of change, or the speed, of the first section was 18 over 0.9. That is his distance compared to how much time it took. And so that's equal to 20. And the rate of change, or the speed, for the second section, oh, what have we got there? Oh, I'm sorry, I've done those backwards. So this is for the second section. And the first section then, first section was we traveled 40 meters over 1 minute. So his speed was 40 meters per second. In the back of your handout then, we have the rate of change of a relationship note. So the rate of change describes how the y variable of a line changes when the x variable changes by 1. So this is again like a unit rate, right? So we can make the rate of change triangles on our graph to illustrate the rise and the run. So when I was doing the runner, you saw me pick a point that I was interested in and draw a triangle. So I'm going to do the same thing here. So the amount that I have changed by is my rise, and the amount that I've changed on the x by is my run. So in this case, it appears that we have gone from 0 up to 6, so my rise is 6, and the run along the x is, I changed from 0 to 1, so my run is 1. Notice again the rise is the change in the y values, and the run is the change in the x values. Okay, so we're going to write down rate of change is equal to rise over the run. And interestingly, if you have a straight line segment, then you can pick any 2 points on that straight line segment, and you will always get the same rate of change. Rate of change triangles can be used to, between any 2 points, but of course it's easiest to pick 2 points that are on the grid line. So what I had done was to pick points, of course, that were right there on the grid line to make it more obvious. So we're going to sketch a line with a positive rate of change, and I'll give you a second to do that. Positive rate of change is just like increasing our distance from the runner yesterday. Okay, so we said we increase our distance when the line rises to the right, so that could be a sample. You also need to sketch a line with a negative rate of change. So that's when we were decreasing our distance. So the steepness here doesn't matter. We could have one that was very steep going down to the right, or we could have something that's not really that steep going down to the right. But either way, we have a negative rate of change. Lastly, we want a rate of change of 0. This is like where the guy is stopped. So we just want a horizontal line. Let's see if I can sketch one here. Not too bad. And then I would like you to draw a line in this blank. This line, blank, has a greater rate of change than this line. So where are we increasing our distance faster? You have to draw that in the first one and slower in the second one. So a sample might be switching then to our course notes. Course note 73 is asking you to calculate the rate of change of these roofs. So we need to remember that rate of change is the rise over the run. And I'm going to pick points on the grid lines. So let's see, that one is definitely on there, and it looks like this one is as well. I'll zoom in here to be totally sure. And I have gone here and here. There's my rise value. There's my run value. It looks like I have run. I'm only counting the spaces. So I start here and move over 1, 2. So the run is 2. Again, starting here and moving 1, 2, 3, 4, 5, 6, 7. So my rise is 7. So the rate of change is rise. Whoops, that's 7. Rise over run 2. So my rate is going to be 7 over 2. This is a fairly steep roof. You're going to complete the rest of these. We're also then going to complete our draft for whatever story graph you were given. So here is a sample. You will pick, perhaps you want to use time, perhaps you want to use distance. Please tell me where your distance is measured from. You're going to pick what you want to count by, so I might count by every other grid line as 1. This is entirely your choice. You're going to count what you want to count by, so perhaps every other grid line is 5 meters here, so I have to state that this is in meters. And I'm going to explain on my draft what I think is happening on this section, so that particular line segment, on this section, and on that section. So there should be 3 different line segments that, or line segments of the curve that you were describing. So please have that draft ready for tomorrow. And if we look back at the assigned pages, if we look back at the assigned pages, then you will be working on textbooks, page 102 and 200, or course notes 67 to 70 and 75 to 80 after you have created for me a draft story. Good luck. Don't forget your quiz on Wednesday.